Assalamualaikum and hello everyone. We are honored to have the opportunity to present our paper at the 9th International Conference on Education, Business, Islamic and Technology 2025. I am ZAINAL Abidin with Kasim from the Department of Mathematics, Science and Computer, Polytechnic Polison on behalf of my colleague, Hajan Nur Hafiza binti Abdullah from the Department of Mechanical Engineering, will present a paper entitled Trends and Evolution of Sustainable Electrical Discharge Machining Research, a Bibliometric Review. Electrical discharge machining is a foundation of modern manufacturing for high-value materials, yet it carries a significant environmental burden. So, what is EDM? EDM is a non-traditional thermal process for hard to machine conductive material like titanium and composite. Where is it used? Critical for high precision components in the aerospace, automotive, and surgical industries. The problem in sustainable EDM. First, the sustainability challenge. EDM label as sustainable due to high specific energy consumption and the creation of toxic waste. Second, the health hazard. The use of hydrocarbon-based dielectric releases carcinogenic pollutant, including benzene and polycyclic aromatic hydrocarbon. Due to the problem matter exists in sustainable EDM, three objectives are developed based on the following points. First, map the evolution of publication trends over time. Second, identify the dominant thematic clusters and intellectual structure of the research. Third, analyze global collaboration network to find strength and strategic gaps. While sustainability is growing concern, a systematic quantitative map of the EDM research landscape has been missing. Sustainability is often an implicit goal, example, optimizing for speed, which indirectly saves energy, rather than an explicit research focus using specific sustainability terminology. The third one, there is no clear picture of the key themes, dominant player, or collaboration pattern in the emerging subfield. In this literature review, we highlight 6 references. That is Ming et al. 2021, that is study on material removal rate. Baumik et al. 2025, study on bio-based dielectric. Mishra et al. 2020, study on vegetable-based biodielectric. Arif et al. 2022, study on biodielectric. Singh et al. 2020, study on productivity and reduce energy consumption. And lastly, Rasuman, study on Voice Viewer. In methodology, we analyzed 2014 high-quality publication from the Scopus database using VOS Viewer to visualize the intellectual landscape. The scope of this study is focused on the 23 years of publication and research in Scopus from 1996 to 2026. The keyword of both are either electrical discharge machining or EDM and sustain star and manufacturing. This slide shows the flow of methodology from data collection in Scopus database until data analysis by Voice Viewer software. This is a full video of methodology using Scopus database and Voice Viewer software to produce the keyword network mapping. This is the chart of publication from 1996 to 2026 on sustainability-oriented electrical discharge machining research. Sustainable EDM research remained a niche topic until 2011, with an exponential surge in activity beginning after 2017. While research is global, India has emerged as the undisputed leader, contributing over 3 times more publications than its closest peer. This is the figure of keyword co-occurrence network visualization generated by VOS-Viewer. VOS-Viewer facilitates collaborative writing among the country and organization. Keyword co-occurrence network represent relationship between keywords. Lines between circle depict connection between keywords and organization. Different colors represent clusters of keywords. Link silhouette thickness signifies the closeness or cooperation between nodes. This is the top keywords by frequency and total link strength as generated by VOS Viewer. From the chart, modern sustainable ETM research is the complex network where sustainability connect process physics, performance optimization, and material science. This map reveals the 5 key research streams that define the field today. The next slide will deconstruct each of these interconnected themes. The map was deconstructed into 5 clusters. First is red cluster. Red cluster focus on the core physics of the process with keywords like electric discharges, EDM, and electrodes. Second one is green cluster that focus on key performance metric like material removal rate, surface roughness, and tool wear. The third one is blue cluster that focus on a single critical theme related to the energy intensive nature of EDM. The fourth one is purple cluster that focus on dielectric fluid, vegetable oil, and sunflower oil. The last one is yellow cluster that is focused on aluminum alloy, titanium alloy, and composite. The table summarizes the number of publications and total link strength for the leading contributing countries. The chart below shows the country collaboration network that also generated by VOS Viewer. So let us discuss the observation from the country collaborations analysis. High research productivity does not necessarily correspond to strong international collaboration, such as India demonstrate exceptional publication volume and citation impact, but relatively limited collaborative linkage strength. Countries with moderate publication output, such as Pakistan and United Kingdom, exhibit strong collaboration intensity, highlighting the strategic role of international partnership in enhancing research visibility and integration. Citation impact appears to be influenced by both research volume and collaborative reach. Countries such as the United States and China benefit from balanced productivity and collaboration, resulting in high citation counts. Our analysis points to 4 clear priorities that will define the next chapter of sustainable EDM. First is biodielectric, perfecting vegetable oil-based fluid, example sunflower polanga oil, to eliminate hazardous waste and minimize environmental risk. The second, intelligent manufacturing, such as integrating Industry 4.0, artificial intelligence, and data-driven modeling for real-time energy optimization and process control. Third one, life cycle assessment, LCA, moving beyond process level optimization to measure the full environmental impact of components from creation to disposal. The last one is global integration, building formal cross-regional research consortia to bridge the calibration gap identified in our analysis. The field of sustainable EDM has fundamentally transformed, driven by a merging of energy, materials, and process innovation. As a summary for sustainable EDM, growth, an explosive increase in research output since 2017 shows the field has reached critical mass and is no longer a marginal topic. Second, integration. The research is now a multidisciplinary blend for process physics, energy efficiency, material science, and environmental science. The opportunity. Future advancements requires deeper international collaboration and the adoption of intelligent data-driven optimization techniques. That's all for our presentation. Thank you very much from us, ZAINAL Abidin bin Abdul Kasim and Haja Nur Hafiza binti Abdullah.